In this video here, we're going to talk about the fundamental theorem of algebra. And the fundamental theorem of algebra states that for every nth degree polynomial, we have exactly n complex zeros. Alright, so here we have a polynomial. It happens to be a fourth degree polynomial. And so we notice that there's two spots where it crosses the x-axis. That means we got two real zeros. But since this is fourth degree, then it's going to need to have a couple more, and we'll see how that happens. So let's start by looking at an example here, and we have a function, f of x equals x cubed plus x squared plus x plus 1, and we want to find all the zeros. Keyword here is all. I want to find all the zeros. All right, the real ones and the imaginary. So we got to start by thinking about the possible rational roots. Okay, and we picked a pretty simple one here. Okay, or the rational zeros. And the rational root theorem states that any rational roots have to be a factor of this 1 divided by this leading coefficient of 1. 1 over 1, so the factors of 1 over 1, which is just 1, is plus or minus 1. So those are the only possible zeros here. So let's try a couple out. We'll use some synthetic division, so we'll copy down the coefficients. 1, 1, 1, 1. They all happen to be the same here, nice and simple. Okay, so that's all the coefficients here. And let's start with positive 1. Let's see if that gives us what we're looking for. Okay, little synthetic division. We bring down the first one, and we're going to multiply 1 times 1, and that gives us 1. We add, then we multiply 1 times 2, and we add. So 1 times 2 is 2, and we add. Multiply 1 times 3 is 3, and we add, and we get 4. So that's our remainder of 4, and that is not 0, so that tells us that this is not a 0. Alright, so let's try it again. Let's try negative 1. So our other possible 0 is negative 1, and so let's copy the coefficients down again, and let's try negative 1. Okay, again, we bring down the first coefficient, and we're going to multiply negative 1 times 1, and that gives us negative 1. We add 0, multiply negative 1 times 0, and that's going to give us 0. And we add, we multiply, and we add. 1 minus 1 is 0. And there's our remainder. And so we found a 0. Negative 1 is a 0. Alright, so that tells us this, that if we take our function, x cubed plus x squared plus x plus 1, that's going to be able to be factored into x plus 1. Okay, and the reason why we choose x plus 1 for our factor here is because this is a 0, and plug in negative 1 here, and that'll make this factor 0. And the leftover comes from right here. So this represents 1x squared plus 0x plus 1, or let's just call that x squared plus 1. Okay, so this guy goes here. Alright, so we've factored this expression initially, and we look at this term here, or this factor, and we want to see if we can factor that anymore. And no, okay, if this was a minus, it'd be a difference of 2 squares, and so we can't factor it anymore, so we're done. Now again, we're looking for the zeros of this function, so we want to know when 0 equals x plus 1 times x squared plus 1. Alright, well, so that means either x plus 1 is 0, or x squared plus 1 is 0. This one's easy to solve. X equals negative 1. This guy, let's subtract 1 from both sides. X squared equals negative 1. And then let's go ahead and square root both sides. And we get the square root of negative 1, which is, and we need our plus or minus also, So we need plus or minus the square root of negative 1, which is our imaginary unit I. And so we have our zeros now for f of x is x equals, and we have a few, either negative 1 or plus or minus I. Okay, so again, checking with the rational root theorem, with the fundamental theorem of algebra, every nth degree polynomial has n complex zeros. The degree here was 3, and so we expect 3 zeros, and we got them. There's 1, and then 2 and 3. 3 zeros. Let's look at one more polynomial here that is a little more complex. We've got a 4th degree. F of x is x to the 4th plus 3x cubed plus 2x minus 2x squared minus 2x minus 4. So it's a 4th degree. According to the fundamental theorem of algebra, we should have 4 zeros. All right, so we're looking for 4 zeros. Remember, a real zero is determined by where the graph crosses the x-axis. So in our instructions here, we're going to find the real zeros on the graph and then use synthetic division to help us find the imaginary zeros. In the last example, we used the rational root theorem to try some possible rational zeros. Well, here we have a real zero of negative 2, and it looks like a real zero of 1. Now that's what the graph looks like, and I think it's pretty convincing. But let's try that out. So with a little synthetic division from our polynomial here, we're going to have, let's undo that. Okay. So we're going to have 1, 3, 2, negative 2, and 4. And we suspect that negative 2 is a 0. So let's try negative 2 in here. And a little synthetic division, bring down the 1, multiply. We're going to add. Multiply negative 2 times 1 is negative 2. Add 0. Multiply negative 2. Add negative 4. Multiply. Oh, what happened here? Let's check. Negative 2 times 1 is negative 2. Oh, I see our problem. Our problem right here is we have negative 4. Okay, let's continue. Let's go back. And we have, well, it still doesn't give it. Negative 2 times 1 is negative 2. We add, we get positive 1. Negative 2, we add, we get 0. Oh, there's our problem. Alright, so let's try this again here. Well, now we're back on track. We were missing a negative here. And so we multiply, we get 0. We add negative 2. And now we're going to multiply negative 2 times negative 2. And we've got 4. And we added that, so we expect. We expect a 0. Okay? Now this represents, right here, a 3rd degree polynomial. So we just found one factor. So let me record what we got. We just found out that f of x, we've got x plus 2, okay, times this whole factor here. We've got 1 coming from our coefficients here. We've got 1x cubed plus 1x plus, now this would be a, let's back up here, squared. So this is going to be a 0x minus 2. Okay? So we have plus x squared minus 2. Alright, but now the question is, can we factor this some more? And so we are. We're going to continue here, and we can just use this 0 here, which is positive 1. Okay, and positive 1 should give us a 0 if we do our arithmetic right this time. We multiply, add, multiply 1 times 2 is 2, and add, multiply 1 times 2 is 2, and add, and we get 0. Okay, so that's what we want. Since we get a remainder of 0, that means 1 is a factor of x cubed plus x squared minus 2, which means that it's a factor of the original function f of x. Alright, so we can now take this and write this as x plus 2 times x squared plus 2x. Oh, let's back up before we write that. Let's get our x minus 1. And that's our 0 that we just found. We just found a 0 positive 1. So you plug that in, that's going to give us a 0. And the leftover x squared plus 2x plus 2. And again, that comes from right here. Okay. All right. So we've factored f of x. And now we want to look here. Can we factor this anymore? Two numbers that add to 2 and multiply to 2? No, they don't exist. So this cannot be factored anymore. So we now can find all our zeros. Okay. Well, we know that we have 0 equals x plus 2. Well, that's an easy one. X equals negative 2. And we kind of already knew that from our graph, right? And then we have x minus 1 could be 0. And that gives us x equals 1. We already knew that from our graph. Okay. And last but not least, we want to know when x squared plus 2x plus 2 equals 0. Alright, and here we have no real solutions, but we've got to use the quadratic formula. So let's use that quadratic formula. Come on down over here. And we know x equals negative b, which is negative 2 plus or minus the square root of b squared, 2 squared, minus 4 times a, which is 1, times c, which is 2, all over 2a. Alright, and that's going to clean up to negative 2 plus or minus the square root of, well, we have 4 minus 8, which is going to give us negative 4 all over 2. And so this is going to give us negative 2 plus or minus, and the square root of negative 4 is going to be 2i. All that divided by 2 gives us, simplify, negative 1 plus or minus 1i. Okay? And so we finally have our zeros, and we have our solution, our zeros. We have negative 2, 1. We have negative 1 plus I, and negative 1 minus I. And those are the zeros. So once again, the Fundamental Theorem of Algebra states that since we have a 4th degree polynomial here, x to the 4th, we should have 4 zeros. And we do, 4 complex zeros. These are complex numbers, even though they have no imaginary part. These are complex numbers because they have a real and an imaginary part. So 4 zeros for 4th degree, and that is the Fundamental Theorem of Algebra.